Okay, so we're going to have another look at part C from question 9. The first time we did part C, we made a very specific assumption. We assumed that the acceleration was constant in the stated direction, and then we treated it essentially as a mechanics problem. So it was dealt with in that way. Now we're going to remove that assumption. So we're going to do this question again, removing the assumption that it's solved as if it was a basic projectile trajectories problem. We're going to think of it through the lens of work energy. So we calculated in part B that the acceleration is 1.0909 times 10 to the 8 meters per second. So if we draw this, we had our magnetic field pointing up, and then we had the particle entering the magnetic field this way, such that this was 30. And then we worked out that this acceleration, because this is an alpha particle here, it has, well, let's put it where the dot I've drawn is. This charge is positive. Now if we point our index finger in the direction of the velocity, our middle finger in the direction of the field, we find our thumb points up. So that means the force is towards us. So force due to the field is towards us. In this case, what's going to happen is the particle is actually going to start cycling. Right? If we remove the assumption that the initial acceleration is fixed and just treat it as a simple kinematics problem, we actually get that this will turn into a spiral, a helix of some variety. So it enters the field, the force will be towards us, and so it will sort of spin it like this as it passes through the field. It will still have some velocity in the direction against the field, but it will sort of start to spin in some kind of helix pattern. Now, if we think about the work done on the particle by the field, the force here is towards us. So since it's perpendicular, the force due to the field does not do any work on the particle. Therefore, from a work energy theorem perspective, both the kinetic energy and the speed of the particle remain unchanged. So kinetic energy remains unchanged, speed remains unchanged in this particular circumstance, right? So if we think about it as forming a spiral, its speed doesn't change. So speed is the same. So this is another way to think about this problem. These problems can be thought of in countlessly many different ways, depending on the assumptions which you start with.